Hey guys, welcome to PyCon. My name is J.J.Behrens. I am a developer advocate for YouTube, also known as a booth babe. It's not working, there's too many guys out there. I think that's a problem. You know how you go to YouTube and you want to watch like an awesome Shakira video and then sometimes like you got to see an ad because Shakira needs to get paid? I'm that commercial, but actually I'm going to do something, talk about something useful. I'm here to talk about using YouTube for Python-based startups. If you're interested in using the YouTube API, there we are on Twitter, YouTube Dev, and then you could also email me at, or check out my blog at giantx.blogspot.com. So let me give you some background information on YouTube. YouTube gets more than 4 billion views a day. Those are video views. 60 hours worth of video is uploaded to YouTube every single minute. Used to be that we would only get like 39 hours a minute and we could fit it on a single hard drive, but these days we had to go to RAID. And then more than 350 million devices around the world are YouTube enabled. And back in 2010, our revenue more than doubled. So it's actually a very profitable business. But, you know, why am I talking about this when I'm supposed to be talking about, you know, Python for, you know, YouTube for a Python startup? You know, how do you guys get a piece of the action? So I'm going to give you 4 strategies to get a piece of the action. You could build content that goes viral and ride the wave. You could build meaningful content and interact with the community. YouTube has a great community. You could integrate your product with YouTube APIs. I'm going to show a little bit of that. And then I'm going to show how you could build new types of applications using YouTube APIs. And then all of these approaches have been successful for various companies. So let me start with this. Backup plan.
Twitterverse, fans get so immersed, but I'm a nerd forever. I'm the new Zuckerberg, and since my website, I've been cooking dough like a chef serving kilobytes. Used to be the basement, back at my mom's place, building web traffic so that we could sell an ad space. Make way for the one name.
Okay, so since I have no useful content, I'm going to start over with that.
Twitterverse, fans get so immersed, but I'm a nerd forever. I'm the new Zuckerberg, and since my website, I've been cooking dough like a chef serving kilobytes. Used to be the basement, back at my mom's place, building web traffic so that we could sell an ad space. Make way for the one-man businesses, bailouts finish with white-collar criminals. Use Sega Genesis, entrepreneur, time making big plans to dominate the online. Yeah, I'm on YouTube. This is one man sharing Google revenue with songs on my webcam. Science is the new art, databases day-to-day. Keep spreading cheat smarts, hustle, make the data pay. I could be in Valleywag plus geekology. Tell from my avatar that I'm most definitely social networks, what dreams are made of. There's nothing you can do. This VC money is brand new. The geek is now damn cool. Let's hear it for Catch me up in TechCrunch, right on the homepage. Hella Monk is Moto in a photo about a phone craze.
Okay, so if you want VC money, don't talk to me. You got to go talk to Paul Graham. So you might be wondering, why the heck did I just waste the like minute and a half of showing you a video? That's actually an advertisement for a VoIP solution, and at the end, it shows you the advertisement. And the funny thing is, the type of people who think that video is freaking awesome, like me, are the type of people who are more likely to need a VoIP solution. And so, you know, you make this video, it goes viral, and then suddenly you don't have to pay for marketing because it's free. But there's other approaches. So let me show you the next one. Okay, so what's that about? So these guys sell skateboards, and they were spending a lot of money on various social networking sites trying to, tune into the skateboarders, and they weren't selling a lot of skateboards, which is kind of a problem if that's your business. So what they figured out is, let's go out, let's shoot some awesome videos, let's post them on YouTube, and then when people are like, hey, where'd you get your board? Let's talk to them. And that is now their entire strategy. They just talk to people online with the YouTube comments. They watch videos from the other people. That's their whole marketing strategy. And I talked to these guys, and they're like, yeah, we're not doing anything else. This worked better than spending money on anything else. This is all we're doing from now on. And so YouTube is a great way to engage with their community. With a TV, you can't really talk back to the customers, but with YouTube, you can. So the next approach to using YouTube for your business is to integrate. We have an open source solution called YouTube Direct, and this is an app engine based application that you could embed into your website and allow users to upload videos to your application. And a bunch of news agencies use this. And so your users could talk to you by feeding videos back to you, and this builds community. The next approach to using YouTube is to innovate. This is the history of jazz. It's an iPad application, and it teaches you the history of jazz. So it's this beautiful application. You leave it on your coffee table, and people come over and they're like, oh, what's this? This is pretty cool. And it teaches you about the history of jazz that shows, videos and music. And the beautiful thing about this is, A, it's a paid app, so these guys are making money like right out of the get-go. And then B, if you like the songs, it has iTunes integration, so you could go buy the music. So they have multiple monetization strategies. And so they're doing integration with YouTube APIs in terms of pulling down videos, and also they have a customized player experience. Okay, so building YouTube-enabled applications. We have two types of APIs, Google Data APIs, these are the back end, and then player APIs, those are the front end. The data APIs, they're Rust-based, using Atom and JSON. I tried to talk them into using something like Corba, but they said no. I don't know why. We have client libraries available for Python and other less important languages that don't bear mentioning. You could upload, search, rate, comment, manage playlists, etc. And you could do things on the user's behalf using OAuth 2. So, you could play with his account, upload videos to his account, play with his playlists and so forth. Using our player APIs, you could control the player and create a customized player experience using JavaScript or ActionScript. And you could do a bunch of simple things using player parameters, and we even have a Chromeless version of the player. And because this is a Python talk, and I'm a Python guy, I figured I should show some Python code. So here is an example of accessing a feed in Python. So we create a YouTube service object, we create a query, we're gonna search for Python, we order it by view count. Here's the feed of when we do the query, and then for each of the entries in the feed, we could print the title and get the URL and do whatever else. And that's about it. It's really that easy. So if you want to do this, just Google for YouTube APIs. We're YouTube Dev on Twitter. There's my blog again. And make sure you read the terms of service and the monetization guide. Now, I'm done. I'm done doing my booth babe duties. I'm here to introduce Mike Solomon. Mike Solomon is the most famous person that you might not know because he was the first employee at YouTube and is responsible for single-handedly delivering every single video when a person clicks play. So, Mike Solomon.
All right, let's start from the back. No, just kidding. All right. Hello, as JJ said, my name is Mike Solomon. I work at YouTube, and it's pretty tough to condense 7 years down into 30 minutes. So I'm going to try and just talk at a pretty high level about some of the techniques we use generally they generally apply to Python, but they apply to all their programming languages. It's just about sort of scalability strategies and how do you solve various problems that end up growing over time. So in my time at YouTube, I've worked on a lot of different systems. So I started out building the serverless infrastructure, doing video indexing, video transcode, full text search, built a CDN, built video delivery, built image serving, and all of these things had the prototypes were done in Python, and the prototypes lived for a surprisingly long time. And today, most of our infrastructure by lines of code is still actually in Python. And every time you actually watch a video, you're going through a bunch of Python stuff. And at last count, there was like over 1 million lines of Python running this thing. So lest anybody doubt, we actually really do use Python in a very, very big way. So the talk nominally is about scalability, but I find that people often confuse or conflate scalability and efficiency. So I'm going to try and pick them apart and talk a little bit about both, because they're both important, especially when things get very large. And I think that's mostly what people are probably interested in, is what happens when things get sort of beyond your wildest expectation. During the time I've worked there, in terms of what has, quote, scaled up, the amount of videos viewed has gone up 9 orders of magnitude, and the number of developers working on it has gone up 2. So, scalability is sort of a problem that has many axes, and it's, how do you write code, how do you, execute code, and how do you maintain it, that kind of stuff. So hopefully this will give you some ideas on how they might apply to your own problems. So very generally about scalable systems, I mean, if I could give you one word about scalable systems, I think the word would be simple. And every time I'm trying to build something new or look at a way to solve a problem, I'm looking for the most simple thing that will actually, address the problem space. And there are lots of complicated problems, but the first crack doesn't have to be that complicated. The complexity will come over time naturally. You don't have to help it out at the beginning. So a lot of YouTube systems, start out from, one Python file, and it becomes some large ecosystem after many, many years. And that whole process is really what, scalability is about. I mean, for me, a scalable system is one that's not in your way, that you're sort of unaware of. It's not buzzwords or anything like that. It's just about a general problem-solving ethos. So thinking about how to express this in a very Zen way. Oh, sorry, let me move these. Oh. There we go. So if I had to pick the DAO of YouTube, this would kind of be it, right? Like the simplest solution possible, the loosest guarantees that are actually practical. And the reason that you want all these things is because you need flexibility to solve problems. And the minute you overspecify something, you paint yourself into a corner. You're not going to be able to make those guarantees, and your problem becomes automatically complex when you're trying to guarantee everything, and you leave yourself no way out. So this is, whenever there's a product design review or like an engineering design review, these are the types of things that we're always looking to encourage. What's the first crack? How are you going to iterate? What do we know about the way that this data is going to get used? These things change over time. So how YouTube was originally designed had no bearing on what it actually became. So does anybody know that YouTube was a dating site? Yeah, there you go. So if we had designed for that, I think we would be having a substantially different conversation. So stay flexible. So scalable techniques. These are probably not new things, but it's amazing how just a few core ideas can apply in a lot of dimensions. So divide and conquer. I mean, this is like the scalability technique right here. Everything is about partitioning out work, deciding how to execute it, et cetera. And this applies to so many things from, in the simplest expression, you think about your web tier. I'm going to have a bunch of web servers, and they're all going to operate independently. That's divide and conquer. I'm going to spray them out. It doesn't really matter. They're all more or less equivalent. I'll process them, no problem. This is also, the crux of database sharding and that kind of stuff. It's all about how do you partition the problem? How do you figure out what kind of communication you need between the parts that you've subdivided? Those are things that you want to think about early on and really influence how the system is able to grow. And again, simple and loose connections here are really valuable. They let you, this is essentially another great feature of Python. Because everything's dynamic, no matter how bad your API is, the first crack, you can pretty much stub or modify or decorate your way out of a lot of problems. So that definitely have used a lot of dirty tricks to get something to work. Approximate correctness is another one of my favorite techniques. This is sort of one of the first rules of systemantics is the state of the system is that which is reported to be. So if you can't tell that your system is fundamentally skewing and inconsistent as from the user perspective, then it's not. So, I mean, a real world manifestation of this is, say, you write a new comment, and somebody on the other side of the world, loads the watch page, and even though the comment might have been made, a microsecond before, he might not get it for, whatever, 300, 400 milliseconds, but he doesn't know that, so he doesn't care. Now you, the owner of that, who wrote the comment, expect to see it. So we should, maybe do a few little tricks to make sure that you see the comment, and that's, you cheat a little bit, right? You cheat so that your system doesn't have to have globally, like worldwide consistent transactions, because that would be super expensive and, kind of overkill. I mean, it's not like every comment is actually a financial transaction. So kind of knowing when to cheat is also, I think that's on the slide, that's another important aspect of scalability. In terms of relational database systems and storage systems in general, I put up expert knob twiddling. It's like, well, what do you know about, what about your consistency model? The comments is a good example. Like, okay, we want to make sure that once they're written, they don't go anywhere. But is eventually consistent good enough? Or is it something else? Like, have you rented a movie? Oh, well, renting a movie sounds like you gave us money and we should do the best we can to make sure that we never lose that. So there are different consistency models based on different subparts of the application as a whole. This is the hallmark of sort of good system design. Every system is tailored eventually to its specific requirements. Jitter. This is like a hot word in our group all the time. If your system doesn't jitter, you get thundering herds. These days, like distributed applications are really weather systems, and a lot of debugging them is it's about as deterministic as predicting the weather. And jitter sort of introduces more randomness because surprisingly things have a tendency to stack up. So a good example for jitter is cache expirations. So if you have a very popular video, we want to cache things as best we can. And let's say we set the cache timeout for, I don't know, like an hour or something, or maybe 10 minutes, or certain other popular content, like the most popular videos yesterday, we might cache for, I don't know, 24 hours or something. If everything expires at one given time, then every machine will observe that expiration at exactly the same time and go back and try and compute it. This is, of course, awful, and this is where you're basically making your own thundering herds. By jittering, you say, okay, well, my desired expiration time is about 24 hours. I'm going to add some variance in there, and randomly I'll jitter between, say, 18 and 30 hours. And that prevents things from stacking up. We use this all over the place because it turns out that systems have a tendency to kind of self-synchronize and line up and try to make them destroy themselves. So, I mean, it's fascinating to kind of watch. I mean, you get a slow disk system on one machine and everybody is waiting on a request. So all of a sudden, all these other requests on completely different machines are now synchronized. And this happens, when you have many, many machines, you have many types of these events, and everyone is actually removing entropy from the system. So you have to put some back in. Cheating we covered. I'm a big fan of cheating. Actually, cheating I should cover a little more, because it's so awesome. I mean, my old boss told me that the fastest function call is the one that never happens. And I have to agree. So one of the things that we did very early on was we would come up with, this is sort of in the approximate correctness vein, is when you have monotomically increasing counters, like say view count or how many times someone's seen my profile, you could do a full transaction every time you wanted to update that, or you could do a transaction once in a while and update by a random amount. and as long as it changes from odd to even, people would probably believe that it's real. So, I mean, you do want the number. You definitely want to get that where the sign the odd even reverses. So, know how to fake data too. It's a good important thing about cheating. Okay, scalable components. What can I tell you about these? You know it when you see it, right? You can look at the general API and have a good feel for how it's going to shake out. Are the inputs well defined? Do I know what I'm getting out? A lot of this ends up being about data. And as the longer I work at YouTube, the more people we work with, the more I think of how critical data really is. Like having a very tight specification of what data is coming out of every function or how it flows actually helps you understand the application without documentation, sort of. You can pop in there and just grab this data object and look at it and say, oh, okay, this is what I need, or this is what this is what's happening after, before and after this function's applied. It also lets you sort of manage expectations about what's coming back and what's not. We are actually not particularly good at this, but we are striving to become much better at this. So we are all learning together. Things have a tendency to move towards RPCs, especially in Python. I mean, things are so fast and loose. It ends up being, the structure of your code is entirely based on the discipline of your programmers. So establishing good conventions ahead of time definitely helps. And when that all else fails, you stick that RPC wall and you're like, all right, I will give you an integer and you should give me a Boolean back, and that's it. That is the sum total of our conversation. And when you have these components, you want to be able to swap them in and out, right? Your component will not be perfect. It may even have a vanishingly small lifetime. Your first version might last a month, it might last 6, who knows? By drawing these lines, you help yourself, you make some of your own luck. When things go south, you'll be able to swap it out and do something different. And sometimes that means rewriting something in Python and C, and sometimes it means, getting rid of it entirely or just tweaking a few things. You don't know until you're able to observe. This is what I was hinting about data. I mean, when you have so many people, it becomes hard. No one can know the entire sum total of the code base. So you have to think about components. I'm like, oh, this is video transcode. Video transcode is definitely distinct from video search and the database infrastructure. So I want well-defined subcomponents. I mean, this is all just like basically good software design, but a lot of these things do end up having to communicate with each other. And in that respect, I find having a good data specification is really helpful. And the greatest sin I think I ever committed was the interface between the servlet layer and the template layer is a dictionary. This is a phenomenally bad idea. You should not do this. It would have taken like all of 10 minutes to actually add a meaningful object that says, oh, this is the watch page, and the watch page substantially has a video, some comments, and some related videos. That would have solved so many problems, because right now it's a dictionary that may have any of like a few hundred attributes, and things are getting better, but I don't want you to think that we always make the right choice. So a little bit about efficiency, right? As I said, it's completely uncorrelated with scalability. In fact, you have to trade one for the other, right? Because the most efficient thing would be to cram everything in one process, write it in C, whatever. But that may not be particularly scalable, especially if you value your own time, right? The big thing is focusing on the macro level, your components, how they break out. Does it make sense to do this as an RPC, or should I just do it in line? Should I break it into a sub-package and just say, okay, well, someday this may be different? Focusing on the algorithms really does make a big difference. And one of the powerful things about Python is the amount of effort to implement an actually good algorithm is pretty low. You have all these built-in data types, but there are some other fantastic features like the bisect module. I mean, this thing, single-handedly, you can take a ratty list that's accidentally sorted and do something meaningful. And you can serialize that list to disk and read it in and then do something very fast. And you could do this in C, obviously, but you'd be inventing a lot of wheels. Python is just sort of there. And yeah, it will be a little bit less efficient in Python, but the overall structure, the overall order of magnitude of all the computations is much lower. And yeah, you'll pay a penalty Python versus C, but overall you're doing the right thing. A big thing about efficiency is obviously measurement, and in Python measurement is a little bit like tea leaf reading. I think you have to get some experience before you're able to make intuitive leaps, and just when you think you should do intuitive leaps, you can make them, you shouldn't. There's a lot of things in Python that are counterintuitive. Cost of garbage collection, all sorts of things. Like most of our app spends its time, most chunks of our app spend its time serializing. And profiling a serializer, it's a lot like a sewer. Like what you put into it depends, what you get out of it depends on what you put into it. So if you test it with like a bag of ints, and normally, that's great synthetic data, but normally if you're putting 4K Unicode blobs in there, probably you should have tested that, because I guarantee you that's going to be different. So what are some ways that we get efficiency in Python? I've enumerated a few libraries, and I'll talk a little bit about them, but efficiency in Python is more about knowing what not to do. There's a lot of really powerful meta-programming things, and how they interact and how dynamic you make things has a pretty direct correlation to how expensive it is to run your Python app. So dumb tends to turn out to be fast. So this is something that we use a lot. And it has other side effects too. Dumber code is easier to grep for, is easier to maintain, is easier to, these are the kind of tools that, I'm an Emacs and grep kind of problem solver. So the more magical our code base is, the harder it is for me to decode how it's actually functioning. These are important characteristics of a really large system. So libraries, ones you've probably heard of, obviously curl. It turns out that pretty much every version of HTTP client-side libraries are awful, and curl is the least awful. And it's pretty complicated to crack into, but the performance is excellent. For an HTTP server. We did a recent project where we swapped out one fairly major protocol for an HTTP implementation, and even though it was in C, in PyCurl, the amount of time we spent sending stuff over the wire was nuts, and we actually ended up ripping out HTTP, doing a direct socket thing with Python, and that ended up being about, on global CPU, about 8% cheaper. So you have to measure, right? Sometimes there are counterintuitive things like this. It turns out that HTTP implementations, the enveloping is just really expensive. Other things, WiseGuy. WiseGuys are fast CGI servlet container thingy, and it's some C code, and it's some process management and pre-forking code. YouTube is not asynchronous. Everything is blocking. YouTube also thinks Apache is real rockstar technology. And every request you watch is actually, every request you watch is going through Apache at some level. So just when you think you have to swap out Apache, you really don't. Spitfire is our templating system. If you've seen Cheetah, you'll probably recognize a lot of Spitfire. It has an abstract syntax tree internally, so it lets us do transformations and some optimizations that end up making it a bit faster. Serialization formats, I could go on for a long time about these, but it turns out that no matter which one you use, they're all expensive. So you should measure, and just measure, and don't use pickle for things. I don't think I should have to tell you this, but yeah, don't use pickle. We did. It's not a good choice. Okay, efficient tools. Apache, and by Apache I mean HTTP server. Linux, I don't think it's any major shock that we're running on Linux. I did some programming on BSD, and I actually worked at Microsoft at one point, so I have some Windows experience. Linux is good in terms of manholes. There's always a way to get in and see how your system is behaving, and the awesome thing about that is that no matter how bad the app is that you've written, at some fundamental level, the resources it's consuming are explorable with basic Linux tools. So this is like a super powerful thing when you're trying to build a distributed system. strace, TCP dump, whatever. MySQL, YouTube uses a lot of MySQL stuff. When you watch a video, you're getting data from MySQL. You're getting a lot of data from MySQL. And sometimes we use it as a relational database, and sometimes we use it more as a blob store. Again, it's all about tuning and making choices in how you organize your data. But anybody who sort of blindly tells you that MySQL doesn't scale or doesn't do something probably has not considered exactly how to solve the problem. There are good fits for MySQL and bad, so it's a good tool. This is a shameless plug. Vitesse is a new project that I'm working on. It's actually written in Go, and it's a front end to MySQL. And this does a lot of query optimization on the fly, query rewriting, and does a lot of proxy and stuff. It's a long project, but we just actually finished our first open source release of a subcomponent. So this is currently what serves every YouTube database request. It's an RPC system. This is what I was citing when I said HTTP turns out to be slow. Zookeeper is the lone piece of Java software that makes me think that Java might be redeemable. Zookeeper is a distributed sort of lock servery thing, and it's in some dimensions that looks like a very reliable file system, and we use it for configuration on a lot of things. It's a really interesting piece of technology. It's also very hard to understand how to use it correctly, so don't just bung things in there. You have to actually read the manual. So productivity. These are sort of nebulous topics. What can I say? I mean, frankly, I believe more in philosophy than doctrine. Like, we try to say, like, simple. All right, make it simple. What does that mean? I don't know, but I'll know it when I see it. Like, if you come to me and your first code review is, thousands of lines and many files, probably there was an easier way for you to do it. And that's how I want you to start. And, your first demo should be simple. Get it working, then iterate. My personal pet peeve is documentation where people put like a function arg called video ID and then a comment saying arg:video ID space, this is the video ID. I'm like, great, now I lost like 2 lines of header, 2 lines, I have a pretty small screen and every line counts, and this line I'm gonna guess, let me tell you, video ID, probably video ID. Please don't write this again. This may be a minority report, but this thing bothers the hell out of me. So more conventions, just how do we organize code? We frankly don't do a lot of object-oriented programming. We do a lot of namespaces. We have a lot of, in C this would be called, I can't remember what it's called in C. And you have the struct and you pass it in. I can't remember. Anyway, we use classes to organize data, and we rarely use them for object-oriented stuff. Back when we started this project and the previous company I worked at, which is also in Python, that was relevant. Module level functions were a lot faster. Now, probably not so much the case. 2.6 has a lot of great caching. I'm sort of running out of time, so I'm going to zoom a little bit and get right to questions, which I think will probably be more interesting than me talking. I don't know where I picked this thing up, but whenever I talk to some really smart dude, I always feel like, what motivated this guy to make these decisions? That's more what helps me make good decisions than trying to actually repeat what he did. So hopefully that's good advice. And so Code Bonsai was a sort of a wacko idea I came up with when someone asked me to do a talk last year. And this is like, what is your code tree going to look like? And these are the words that I wanted people to use when they describe my code tree. I don't know if anybody looking at the actual YouTube code tree would use too many of these, but in my like falsely idyllic world, this is what it looks like. And just to give you a little visualization, this is what I'm hoping for, right? This is sort of closer to reality. Yeah. So let's just do questions and see how it goes. Far left.
If you can use the mic, if we can start right here.
First person to the mic, go. No. Okay.
If you could talk a little bit about the YouTube CDN or any specific things that you use there in terms of.
The first question is about the YouTube CDN. Very briefly, so YouTube originally contracted out some CDN work for video and for image serving. This is, of course, psychotically expensive, and after some point, it makes sense to do it yourself. So it turns out that you can build a pretty good video CDN if you have a good hardware dude. So you basically build a very large rack, stick a bunch of machines in it, put a good switch in, then take Lighty and override the 404 handler to be a piece of Python that knows where to find the video that you didn't find. That took 2 weeks, and on its first day served 60 gigabits. So that was the first incarnation of the YouTube CDN. Your mileage may vary, but you can do a lot with really simple tools. That is all true. Next question.
Hi. First of all, I just wanted to say thanks a lot. There was a lot of stuff in here that we were nodding about. Our shop isn't quite at your guys' scale, but we've been going through a lot of these experiences over the last couple of years. We're at about 80 million users now and have run into a lot of the same things. I also just wanted to actually tell you about one thing. There's a we were using protocol buffers for doing lots of passing, and the Python protocol buffer library, right, on 2.3 sucks. On 2.4 is like experimental C++ bindings, but they're kind of unstable. We wrote a replacement that's all C with a thin layer. It's called POM, and it's on GitHub.
Come talk to me after.
Okay.
We'll figure that out.
I had a feeling you might have been kind of like we were spending all our time serializing. So anyway.
So YouTube for a couple of massive systems uses, the question was loosely, we're trying to use protocol buffers. Are protocol buffers actually fast? And the answer is kind of no, but they're going to get better. Obviously, this is a big thing about measuring. We use BSON. We have a BSON implementation that we wrote that is 10, 15 times faster than the one you can download. We are open sourcing it as part of the Vitesse project, so we'll give back.
Yeah, that's interesting because we used Mongo's BSON library for a while too. That was our replacement because PBs weren't doing it. So anyway, cool. Thanks.
We have enough time for one more question. Try to keep it short if you can. Thanks.
What would you say to those of us that have the misfortune of needing to implement a new feature on a system that's already receiving a lot of traffic, mirroring production traffic or writing a good simulation of existing production traffic?
Oh, so the question is, how do you change the wheels while the car is running? So yeah, I mean, I've done a lot of large-scale data migrations, and I mean, every system is entirely different. Right now when we do a big data migration, we frequently route some percentage of read traffic, and then the writes pretty much you have to be real sure that it's going to go. You run a simulation and cross your fingers. And so far we haven't had any major disasters, but that's pretty much the only recipe there is. You can't, at some level you make the decision on how you're going to access one data pattern versus the other. It's kind of a hard question to answer without more context about your app, but hopefully that's something. All right, thanks guys.